Good afternoon, everybody. Welcome to another wonderful afternoon of Chem 170 with your host, me, Dr. White. Hope you all had a great time since we last met last Wednesday. I had a lot to do, like grade tests, and hopefully you all realized that you should have seen in D2L your grade for test number 1, and you should have also gotten an individual email with the points that you obtain for each question or answer, actually each answer on test number 1. Now, what I'll be doing is I'm going to go through test number 1 in a little while. I'm looking to see what other announcement, but I'll do that and I'll explain something in a second. Let me just remind everybody, remember last Wednesday, the second lab was due, so hopefully you handed it in. I posted in D2L those that did hand in lab 2, plus I also did lab 1. Your scores are in there. Now, as you know, in my class, in my world, there's no such thing as a dumb question. And that means anything I grade and give you a score for, always feel free to ask me in private, why did I do that? Or what was the reason I got that score? And I'll always be more than happy to explain. All right, what we're going to do, I'm going to go through test number 1, the answers. I'm going to cut that out of the video, this one, and post it as a private video, which I will be sending out an email, just like I did with the method, where you can go on my YouTube channel with that link. And I like to just keep it private. And later on, I'll delete it later in the semester. I was going to think of something, just zooped out of my mind. But anyways, don't forget, hand in labs. Oh, I know what I was going to say. When I go through the test, I'm going to go through all the answers. If you have any questions about why I took off points, and I do this face-to-face, don't ask while I'm going through the answers. Let's do that in private, and I'll be more than happy to explain what I did. Same thing, if you don't want to do it today after class, feel free to come to my office hours on Tuesday and Wednesday. All right, let's get going. Going once, going twice, going 3 times. Okay, well, I'd have a question. What grade am I getting? Well, forgetting about the labs, if you got 90 and above, you're getting an A right now. There's still a lot of points. 80 to 89, this is in my syllabus, B. And I think everybody was in that group, or 70, 79 is a C. Now, the class average, which made Dr. White very happy, was an A, not an A, I'm sorry, 88, which is almost an A. Thank you. Now, listen carefully. If you didn't get the grade you wanted, as high as you want, everybody still has a chance to get an A, because the lowest test is dropped. There's still a lot of points to go. If you have any problems and want extra help, always feel free to come to my class and ask after class, or come to my office hours and get help. Or if you can't make my office hours in class, email me and I'll see if we can set up a private Zoom meeting for me to help you. But most of you did really good. And now you understand why I call them practice problems. All right, let's move on. One thing, first of all, before we move on, public service announcement from the management. Me, last week we finished alcohol chapter. This Wednesday, I will go through in class the alcohol's problem set. So I highly recommend that you try it before I do. All right, last week we started on a new functional group called ethers, and I'll also cover today epoxides. And an ether has this functional group, oxygen, with 2 R's on it, and they can be the same or different. Oops, wrong color. And here we have an ether. How do you know? It's an oxygen with 2 R groups. It doesn't matter what I call R and R prime. And I taught you last week that I'll only ask you to know the common names, and you name each R group as an alkyl group and add the word ether. So with that, why don't you figure out what's the common name for that molecule? Oh, I just remembered the other thing I was going to talk about. As soon as we do this, I'll do that. Again, what's the common name for that molecule? And when you're done, don't forget to vote yes. All right, I think everybody's done, so it's my turn. And it's an ether. How do you know it's an ether? It's ROR prime. And the R group is methyl. The R prime is N-propyl. And it's an ether, so at the end we put ether. Now, since this is a common name, you could have also written N-propyl methyl ether, and that would have been correct. Now, I just remembered, and I'll do it now so I don't forget what I forgot to do. This morning, I started teaching what's called Chem 1105, a general chemistry at College of DuPage. And they set this up, this is a 12-week course, which is why it started much later than ours. And it's also a net course like this, and I'll be posting on a different YouTube channel the videos for that class. And the reason I'm telling you that is, starting now, I've got 2 videos to process and upload to YouTube. So this might be a little later. By tomorrow morning, 10 a.m., I will have the video for each of our now Chem 170 lectures on YouTube. Before last week, say, since I didn't have the other one to deal with also, I could get this one out quicker. But as I said, by tomorrow morning, 10 a.m., the video will be here, just a little later than it was. All right. Now, this is an ether. Oh, let's do one more. I'll tell you what, why don't you draw this structure? Draw the structure of diethyl ether. Your turn. And don't forget to vote. I think everybody's done. How do you decode this? You start from the right and move left. Ether is this. And di means 2-ethyl. Now write it this way. And this is diethyl ether. And you could have written another way too, which I rarely see, but you could have, and I would accept it on its S, like this. This is rare. This is the normal way you'll see it. Now, one of the questions you should be asked, always in my class is, why am I learning this stuff? And ethers, diethyl ether, is probably the most common, widely used ether of all the ethers. When I was in grad school, I went through a lot of this in my research using it, but diethyl ether is this structure. Now, switches off, but ethers are low boiling liquids, most of the smaller ones, and they're flammable. They make gasoline look like water. That's how much more flammable they are. And diethyl ether was found to be an anesthetic, an inhalation anesthetic. You inhale it and it puts you out, which was found a couple of years before the American Civil War in 1860. I think in the 1840s, doctors found that out. Unfortunately, it was heavily used during the Civil War, where there are a lot of soldiers that had to get operated on, unfortunately. Now, the one bad thing of diethyl ether, it's flammable. If you have someone nearby where you need a candle or a lamp to light up the operating room back in the 1860s, you could have a serious fire. And even in the 1900s, if a surgeon was cauterizing a wound and there was a spark, well, the patient, their lungs were filled with this stuff, could die, and your surgeon could get his hands or her hands burned and no longer be a surgeon. Well, it turns out when you replace hydrogens in a molecule with halogens, that makes it much, much less flammable. Does everybody see isoflurane, which is a trade name or a common name that's on your screen? And over on the right, you can see you have an ethyl group and a methyl group, and most of the hydrogens have been replaced with halogens, fluorines and chlorine. And this is less flammable, like almost I wouldn't say non-flammable, but it has a very low flash point or burn. It's harder to burn. Now, a personal story from me, Dr. White, and I told you you'd learn a lot about me. When I moved into this house long ago, I did some stupid thing. I was picking up 2 boxes of books at a time, and I didn't have a weight belt on, and I was moving them. That was about 120, 150 pounds. Well, guess what? I popped a hernia. And I went, a friend of my brother-in-law's had a surgeon. He had actually done heart surgery on this person and other types and said, this guy's good. And it was. And I went in and said, yep, you got a hernia. I got to operate on you. And said, when he did some further examination, yeah, your other side's about ready to pop too. So I had an operation, and it was interesting. I didn't know something about the surgeon, and that is he was never on time, always running late. So I had it at this hospital in Evanston. You know how if you've ever been being operated on, before it starts, they get you into the gown, put you on a gurney, and wheel you outside the operating room. And I could see a big clock on the wall, and the operation was supposed to start at 1 o'clock. And I got there about 10 to, or maybe 5 to 1, and I'm on my back. I'm looking at the clock. It's 1 o'clock. It's 1:05. And one of the doctors came over to me, said, oh, I see you're looking concerned always at the clock. You don't know something about your surgeon. I said, what? And he said, relax, he's never on time. And he asked me, what do you do? And I said, I'm an organic chemist. And he said, well, I'm your anesthesiologist. And he brings a bottle over of stuff and says, this is what we're going to use as the inhalation anesthetic. And I could see the ingredients label. I said, oh, that's a molecule that has 2 carbons with fluorine and a chlorine. So, oh, he said, I got to leave. What's wrong? I got to get to work. I said, what do you mean? Can't you tell your surgeon's here? Well, he had his mask on. He came over and said, I'm sorry, I'm late. And the operation, it was major reconstruction, took 5 hours. Afterward, I was in pain for a while. But in case you were wondering, I lived. And that was many years ago. And he did a super job. I've never had a problem since. But that's the use of ethers. Important use. Now, how do you make ethers? And that is the best way is called the Williamson ether synthesis. You take, and this is called an alkoxide plus an alkyl halide, remember X, and I'll write it on the whiteboard in a second, and react it, you make an ether plus sodium halide, a salt. That's not what I want. Still not what I want. There's what I want. All right, how do you make an ether? X equals chlorine, bromine, or iodine. Now, one of the things I'm not doing in this class is putting reactions conditions like what temperature do you run this at? And also, do you need to do this in a solvent? Things like that I'm not going to cover in this class. But this, you make an ether, and plus, this is inorganic. Which salts are, and you don't have to write that down because you know on my test I ask if the organic product or products. Now the important thing, this oxygen is bonded to the carbon in R prime that has the halogen. This oxygen is bonded to the carbon in R prime this new bond right here, that the carbon that had the halogen. I'll teach you later on how to make an alkoxide for a lab, but I won't have it on a test. And the question would be, give the organic product or products for the following reaction, 3 points each. Well, how do you know what to do? You look for what's different, what's not carbon, what's not hydrogen, get your attention like that, or carbon-carbon single bond. But here we have a carbons on an oxygen with a sodium cation. That's called an alkoxide. I will never ask that on a test, but I'll use the term. Here we have carbon, halogen on a carbon, alkyl halide. X can be chlorine, bromine, or iodine, in our case it is. And you form an ether. I'll put it down, but you don't have to, and a salt. And what's my R group? Methyl. What's my R prime? And this is the carbon that has the halogen. Do you break carbon-carbon single bonds? No. So I'm going to have my R prime, then my oxygen, and the R prime, the oxygen's bonded to the carbon with the halogen, and then I can put it anywhere here, but I'll put it here. I have my R group. And you've just made, you could also write it, let me put it into hydrogens. Each oxygen to carbon is one bond. You could have also written it this way. These are the same. And it's both methyl isopropyl ether. So remember, the halogen on the carbon in the R prime is the carbon bond to the oxygen in the ether. Well, I better share the fun. I haven't done it yet today. Well, I did a little with the nomenclature. And the question is, give the organic product or products for following reaction, 3 points each. Your turn. All right, it looks like everybody's done. So the question is, what's the product or products for the following reaction, 3 points. What's different? Ooh, oxygen cation, sodium cation with an R group, carbons. This is an alkoxide. Ooh, carbon, 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 hydrogen, ooh, halogen on a carbon. That's an alkyl halide. Remember, X can be chlorine, bromine, or iodine. In our case, it's bromine. And one way of thinking of it, this attacks that and bonds to the carbon, kicks this out. But I'm not doing mechanisms, unfortunately. I don't have time this semester in a 1-semester course. And you form an ether plus a salt, but this is inorganic, so you don't need to worry about that. So what's my R group? Ethyl. What's my R prime? And butyl. Do you break carbon-carbon single bonds? No. So I get my R group, 2 carbons, my oxygen, then the carbon with the halogen from R prime is the carbon this oxygen we bonded to. And that's the end of 4 carbons, because you know you don't break carbon-carbon single bonds. And there are 4 bonds to carbon. And I've just made ethyl and butyl ether. And that's how you do it. If I look at the clock, oh, it's time for a break. Let's take a 5-minute break. I'm going to get up and stretch, and I'll see you in 5 minutes. Time to get going. All right, we were talking about ethers. Oh, I see a message I missed. All right, don't worry. Hold on 1 second. All right, let's get back to ethers. And remember, ether, you make with the Williamson ether synthesis. Now, on test 2, unlike test 1, I will have usually 3 or 4 synthesis problems. I wouldn't do a whole test of synthesis problems because that's cruel, unusual punishment. I think it's still outlawed by the Supreme Court. Even if it wasn't, I still wouldn't do it. But I will put a couple of synthesis problems. So and let me do one, then I'll let you try one. So if we look at this, the question is, what 2 things do we react to make these 2 products? And how do you do that? You look at the product. Ooh, carbons here, R group, oxygen, more carbons, and ether. Wait, we have sodium chloride, that's a salt. And X here can be chlorine, which it is, bromine, or iodine. And how do you make an ether? Williamson ether synthesis. Alkoxide plus an alkyl halide. So I'm going to call this R and this R prime. And therefore, my alkoxide is this, and my alkyl halide, what's the halogen? Chlorine would be this. So that would be your answer. But wait, I can call this R prime and this R. And if I did that, oops, I meant R. And therefore, what's R? Ethyl group. And that's my alkoxide. The carbon that the oxygen is bonded to is either the alkoxide or the alkyl halide. And then my R is methyl. So the question is, which is the right answer? And the answer is, they both are for this class, because either one will give you the product we're trying to make. Now, I'm one of the probably 2 organic chemists at ECC who would know the following. Since I worked many, many, many years in industry, there's something called cost accounting. And in fact, when I got into senior management, one of the things I regretted as an undergrad or grad student was I didn't take a basic accounting class. It was when I got into senior level and went into certain board meetings, I didn't know what they were talking about accounting wise. What's a gross margin? I got from my accountant a basic accounting 101 book and learned. But part of cost accounting is in a chemical company, you want to maximize your profits. Therefore, you use the cheapest raw materials, starting materials. And I know I'm not expecting you. This is cheaper. That's the cheaper way to go. But on a test, either way would go. It's your turn. This would be something maybe on a test, 4 points, give the starting materials. And as a special service, I put 2 question marks that tells you there's 2 things. When I took this kind of class, my instructor wasn't that nice. Don't tell anybody I'm being nice. I'll ruin my image around here. And this is the fun part of organic chemistry. How do you make things? How do you determine what do I start with to make this compound? I don't know about where you live, but where I live, because of the warm weather we've had, all the snow we got last week is gone. Yay. And please be patient. I try and give everybody time to finish. All right, I think everybody's done. So my turn. How do you determine what are the starting materials? You look at the product and look for what's different. What's not carbon, what's not hydrogen. Ooh, an oxygen. Carbon's here and here. That's an ether. Oh, wait. And we also have a salt. Remember, X can be chlorine, bromine, or iodine. In our case, it is. And how do you make an ether? The Williamson ether synthesis. Where you take an alkoxide and an alkyl halide. So I'm going to say this is R prime. Well, if that's the case, here's my alkoxide. The carbon with the oxygen is the carbon with this O minus and A plus. The carbon here with the oxygen, R prime, is the carbon with the halogen. The halogen is iodine. And I know there are 4 bonds to carbon, so I put that there. Whatever you end up, you better start with because you're not breaking carbon-carbon single bonds. But wait, I can call this R prime and this R. Here's the carbon with the oxygen bond to it, will be that carbon with this. So my alkoxide is this. then my R prime, and the halogen is still iodine. And either one of these, let's call it A and B, would be a correct answer on a test. Probably A would be cheaper cost accounting, but for my test, my class, I'm not asking to learn cost accounting. In fact, at the other school I teach, I don't think any of the organic chemists know cost accounting. I think I'm the only one there who's had actual industrial experience. All right, on a personal note, ethers are very handy in organic chemistry. Switches off, click. They're called aprotic solvents. And A means without protic proton, H+, which is in water. And a lot of times they'll react with things, and you don't want it to. So 2 ethers that Dr. White used a lot, and you use them as a solvent. And again, switch is totally off. I'm just bringing back old friends. Diethyl ether. Another one, a cyclic ether, a ring where one of the carbons is replaced with an oxygen. So this is also an ether. This is called tetrahydrofuran. That's the common name, but everybody knows it as CHF. And I used a lot of this for my research in the reactions I was doing at Michigan State. A lot. All right, so that's how you make ethers. And guess what time it is? It's new functional group time. Yes, new functional group time. Now, you know, I'm an organic chemist, I get excited about a new functional group. And this is an epoxide. An epoxide has the following overall structure: 2 carbons and an oxygen in a ring, and each carbon can have R groups. They can be the same or different. And this is an epoxide. Now, at first glance, you can say, oh, that's a cyclic ether. And the answer is no, because ethers are very unreactive chemically. Epoxides, well, they're really reactive. And in industry, I work with these a lot. Oop, wrong one. Right one. Now, I'm only going to talk about one epoxide. And that's the simplest one. I will never ask the name, but I will tell you the common name of this is ethylene oxide. Now, I'm going to try and be a good teacher and not use slang, because if you work with this in the chemical industry, we call it EO for ethylene oxide, but I'm going to try and always use it. And ethylene oxide is an epoxide. They're very reactive. I worked with this at a couple of companies. And the dangerous thing about ethylene oxide, if you get oxygen into us, and it's a gas or a pressured liquid, into a tank of that, it can blow up, seriously. And one company I worked for, it used to be called the Maser Company of PPG, Pittsburgh Plate and Glass, was about 5-7 miles northeast of Great America in Gurnee. And we had both a research center and a production site, a plant. And they had a couple, I think, 1,000,000-pound tanks of ethylene oxide. One Friday afternoon, a bunch of the research chemists, like we would do it, and a lot of companies do this, 10, 15 minutes before you leave on a Friday. Everybody's cleaned everything up. We're sitting around talking, and someone said, if our ethylene oxide tanks blow up, would we take out Great America? Because everybody in that room knew we would be dead like that. We wouldn't even have to think about whether we would survive. No, you're gone. And the consensus was, I think Great America was 5 to 7 miles away. It wouldn't kill anybody, but the shock wave from the explosion could damage some stuff and injure some people, but probably not kill them. Nice thought to think about. But ethylene oxide is an amazing chemical used a lot in the industry to make things used in daily life. Now, the switch is off, click for this reaction. I just wanted to show you, when you work with ethylene oxide, you don't want water in your reaction. Why? Because ethylene oxide reacts and you break this bond. And remember, water is HOH. The H goes here, the hydroxyl group here, and you make ethylene glycol. This reaction will not ever be on a test of mine. In other words, you consume some of your reactant and you make something you don't want. So whenever you run a reaction with ethylene oxide, you make sure it's anhydrous, no water present. But a reaction, click, switches on, reaction of an alcohol with 1 molecule or mole of ethylene oxide. Remember, a mole is the chemist counting unit. Did I tell you about my all-time favorite gift I want? A mole of pennies. Remember, a mole is 6.02 times 10 to the 23rd. That'd only be $100 million billion. It's just pennies. But let's look at this reaction. If you take an epoxide, ethylene oxide, react it with 1 molecule of an alcohol, you make this new ether alcohol. And these are widely used in chemistry in our daily life. Now write it this way: alcohol plus ethylene oxide and you break one of these bonds and the H goes to the oxygen and this part goes to the carbon. And you make this ether. That's what that is. Alcohol. And I work for a company that made a lot of these products, different R groups. Let's try one. And what do we have here? And the question is, give the organic product or products for this reaction, 3 points. I have an alcohol. Ooh, this is different. A ring with 2 carbons and oxygen, ethylene oxide. And you get this ether alcohol. Now, I don't have in this example, but the carbon with the hydroxyl group is a carbon this oxygen is bonded to. The carbon with the hydroxyl group will be the carbon this R group is bonded to. In this case, R is methyl, oxygen, CH2, CH2, OH. And that's how you do it. And you've made that ether alcohol. Now, these products and another product I'll show you are found in a lot of places. One place that you find them, when ours is a little longer, are in personal care products like skin lotions and other things like that. And I'm going to share the fun. And here's some fun for you. Give the organic product or products to the following. By the way, UPAC has rules how to name that ether alcohol, but I'm not going to ask you to learn them. And remember, please give everybody time to finish. All right, my turn. How do we do this? We look and say, what's different? What's not carbon? What's not hydrogen? Oh, oxygen with a hydrogen, hydroxy group and a carbon. That's an alcohol. And this is, well, you got oxygen there in a ring. This is ethylene oxide. Notice I've been good. I haven't used slang. And alcohol, ethylene oxide, you get this ether alcohol. And what's my R group? An isopropyl. The carbon with the hydroxyl group is the carbon. This oxygen is bonded in my ether alcohol. And we don't break carbon-carbon single bonds. So I have 3 carbons, O, CH2, CH2, OH. And I know there are 4 bonds to carbon. And I've made this ether alcohol. Now, as a public service, don't tell anybody I'm being nice. Shh. On this reaction, the next one, dealing with epoxides, ethylene oxide, I will never give a synthesis problem. It's pretty difficult. So I'm going to be nice on this and next reaction on test 2, and also the final, I'll never give a synthesis problem. But let's do another one. And the question is, what's the organic product or products that are following? And I'll try and give everybody time to finish. Finish. All right. I think everybody's finished. So how do we determine what's the product or products for this reaction? We look for what's different. What's not carbon, hydrogen? Ooh, oxygen, a hydrogen, and a carbon. That's an alcohol. Then we have ethylene oxide. And we get this ether alcohol. What's our N-butyl group? The carbon with the hydroxyl group will be the carbon this oxygen is bonded to. You break carbon-carbon single bonds? No. So I have 4 carbons, my R group, oxygen, CH2, CH2, OH. And now I know there are 4 bonds to carbon, so I can put in the rest of the hydrogens. And there we go. Now this is called N-butoxyethanol. And that's, I think, the common name. Or maybe not, it could be IUPAC too. And one of the things I've been saying more and more in my class is, why are you learning this? That's a question you should be asking me or yourself. Well, the obvious answer is you want to get a good grade. Someone said you had to take a 1 semester organic. But why are you learning this? Well, this molecule, 1-butoxyethanol, let's go out to the real world. Now, you see on your screen the easy oven cleaner fume free? We'll say that 5 times quickly. No. Everybody see that on your screen now? Give me a thumbs up. Thank you. Well, the key ingredient in this product, and it does a great job. I've used it on mine. I also do my sister's oven. She's older and I'm a chemist, so I know how to handle this stuff. And also I like to help her out, is 2-butoxyethanol, the molecule you just made. Now, there's another use, and I have to talk about something not that pleasant. Now, I don't know if you remember, wow, it's that long ago. Back in 2010, in the Gulf of Mexico, near New Orleans, in that area, there was a tremendous environmental tragedy. And that's an oil well that was owned by BP, had a serious problem, and it's broke, and there was a major oil spill in the Gulf of Mexico. Now, they claim there are about 210 million gallons released. I did a calculation based on what I knew they were drilling, based on what was in the papers, and it was a lot more than that. But over 200 million gallons, even that number was amazingly bad. That's a polite way of putting it, awful. Now, turned out I was listening and following because I'm an organic chemist, and to dissipate the oil, because oil is not soluble in water, they use what's called an oil dispersant. And that oil dispersant was made by a company, Nalco, in Naperville. It's now owned by a French company. And if we scroll down, Trying to find a name in here. Here's what I'm looking for. They used a product called Corexit dispersant, and this was made by Nalco, and there are a couple of different versions. And what I found, knowing the internet, they've hidden it now, but back then I found it easily. The key ingredient in Corexit 5912, I think it was was 2-butoxyethanol. And one of the things I'm going to teach you right now is if you're unsure of a chemical, put the name of the chemical in your favorite search engine and put MSDS or MSD. And this is the material safety data sheet, or sometimes it's called safety data sheet. And if we go to Sig Aldridge, this one was easily available. Let's go Parachem. Here's the material safety data sheet, and they're standardized for chemicals I've even created. I've helped write these. And the first one is the product name, and next one is hazards. If you look here, acute toxicity, both dermal, inhalation, skin, and if you read down here, they also have what it will do to things like, here I can't find it right away, but usually there's a section about how it will affect marine and other animals and humans. And here is stuff is really toxic. Well, when I read that and found out about 2-butoxyethanol, which is about 60% in the Corexit, and to disperse all that oil, they pumped, this is so sad, about 3-4 million pounds of that Corexit. So you're putting a couple million pounds of that 2-butoxyethanol into the Gulf of Mexico. Well, being a socially responsible person, that's how my parents raised me, and also being an organic chemist, I got through to the Coast Guard, second command. He said, oh, our organic chemist, or our chemist, said it's not bad. So why don't you call him? And they gave me his number. And it turned out it was an analytical chemist, not an organic chemist, who was an academic chemist, no experience in the real world like I have. I told him, this is wrong. It's dangerous. Look at the MSD. Oh, we've been told by Nalco it's not that bad. I went back to second command. He said, well, our chemist says it's not bad. And he blew me off. Well, you don't do that, Dr. White. I got on the phone and I reached MSNBC, the New York Times, and a few other places, and told them about the dangers. I'm probably not the only one. And within 24 hours or less, those news organizations were saying, this is dangerous stuff. And finally, the EPA made them stop using it. But by now, they had pumped millions of gallons into the Gulf of Mexico. Fast forward about 5-6 years ago, about 10 years after, about 3-4 years ago, I saw something on the internet about an article. Somebody was doing a follow-up, and he had actually been on one of the boats trying to clean the oil off the surface and was exposed to 2-butoxyethanol. And I couldn't get through to him, but the author of that article I did. And he said, I told him what I had done back in 2010. He said, let me give you the phone number of this guy. I'll tell him you're going to call. And I did. We talked, and he told me a very sad story that 10 years later, a lot of the people who helped to clean up on the boats and on the beaches were affected exactly how it said in the MSDS sheet. And this is sad. And he told me about what he was lucky he wasn't that sick, but he had been affected by it too. So unfortunately, there are good things and bad things you can use chemicals for. You just have to be careful and understand the material safety data sheet. All right, let's do something. Do not copy this down unless you want to, but let's have some fun with this reaction. And if I do this reaction, which I did earlier, alcohol plus ethylene oxide gives you this ether alcohol. Here's my R group. So I'll get this ether alcohol. Now, if you notice this molecule, I have an alcohol, and my R group is now this. So I can react this with more ethylene oxide. And now what I'll make, and again, you don't have to copy this down. Here's my R group here, then my OCH2, CH2, OH. And this new molecule, what do I have here? An alcohol. And I can react this with more ethylene oxide, and I will. And here's my new R group, so I'll rewrite that. Here's my R group. Then I'll have OCH2, CH2, OH. And I could keep on reacting this like the Energized Bunny. It keeps on going on, bang, bang. But anyways, if you remember parentheses, when you have a repeating unit, you can write it in parentheses. So notice I have 1, 2, 3, OCH2, CH2. And I can write this like this. Also, notice this is outside of the bracket. Now, let's look at this. How many times did I react ethylene oxide with my alcohol? 1, 2, 3. And that corresponds to this number. So I've reacted 3 molecules or moles of ethylene oxide, and this is the product I get, which leads us to the next reaction. That's where you react alcohol with N moles of ethylene oxide. And you get this product where N is the number of moles of ethylene oxide. And this reaction I have run both in a lab and supervised in a plant where N can be very large. Most companies usually go up to about 25, but for special samples, I've seen it done up to 100, and you could probably go higher. So let's take a look at this. Forgot to write the general reaction first. You take an alcohol and react it with N moles or molecules of ethylene oxide. You'll make this poly, meaning many, ether alcohol. where the number of times it repeats N comes from the moles. Now, it's important, common mistake students make. This hydroxyl group is not inside the bracket. This hydroxyl group is on the outside. So let's have some fun with this. Oops. And this reaction I'll never give as a synthesis problem in this course on the test or the final. So if we look at this problem, this reaction, and the question is, give the organic product or the products or the following. What's different? Ooh, hydroxyl group on a carbon, alcohol. Ooh, ethylene oxide, but ooh, this is different. I've got a coefficient, the number in front, I'll call that N for now. And what you get is this polyether alcohol. Remember, the hydroxyl group is not inside the bracket. So what's my R group? This. And then I have my OCH2, CH2, close bracket. What's N? 5. And that's the molecule he made. And these are type of polyether, poly. Remember, this repeating is an ether. And poly means many. Polyether alcohol, because here you have your alcohol on the last carbon of the OCH2CH2. And I better share the fun. I don't know if I told you, but this is how I write my 7 the German way. I learned that in German in high school from our German teacher. I thought it's the coolest thing in the world, and I still do it. It's cool. In case you don't know, Dr. White always tries to be a cool dude. So the question is, give the organic product or products for the following reaction. And while we're waiting for everybody to All right, think everybody's done, so I better get to work. And the question is, what's the product or product of the following reaction? And you look for what's different, what's not carbon, what's not hydrogen. Oh, oxygen with a carbon, with a hydrogen and a carbon, and alcohol. Then we have, a number, N moles of ethylene oxide. And what do you get? You get this polyether alcohol. What's my R group? This right here. Now, the carbon with the hydroxyl group is the carbon this polyether is attached to. Do we break carbon-carbon single bonds? No. 1, 2, 3, 4. The methyl group is still here. This is the carbon with the hydroxyl group. It's bonded to OCH2, CH2, close bracket. Remember, the hydroxyl group does not go inside the bracket. What's N here? That's the coefficient here. That's this number, 7. And that's how we get it. And we made this polyether alcohol. How are we doing on time? Why? It's time to take a break. And so let's take a 5-minute break and we'll come back. And I've got something really exciting to show you. And I'll also tell you a real spooky story. I mean, really spooky. See you in 5. time to get going. Well, I promised when we got back, a really spooky, still does that to me, story. I talked to you about the PPG, the Mazer PPG company that I work for. I was hired to fix their quality control lab. They're having serious problems. And one of the areas, and this isn't going to be on test, this is spooky, I mean, really spooky, was the quality of their polyether alcohols. And the key test took too long, and that affected the quality to measure when are you done. I'm not going to go into that chemistry. Well, anyways, someone at their corporate headquarters in Pittsburgh had developed this quicker test that wasn't working well. And one of the things, besides fixing their overall quality control, I was asked to fix that test. And I worked on it for a little while, and I said, something's not going on right, and it's not working well. It's not a good test. So I talked to a senior supervisor, person who hired me, and I said, yeah, I need to talk to whoever developed this test. And he said, oh, you need to call in Pittsburgh, Dr. Dahmer. And throughout my life, sometimes I'll say something in jest, and I said without thinking, that's not Jeffrey's father. And my supervisor said, yes, and please don't ask him about his son. If you're not familiar with who Jeffrey Dahmer, and at that point he was still alive in prison, he was this horrendous person who killed a number of men and then cut their bodies up and saved them in his freezer. I think he killed more than 10 people, sad. And every time I talked to Dr. Dahmer, in the back of my head, I think it was over here, was saying, a little voice was saying, ask him, what happened to your son? What went wrong? I never did. He was a nice person. I never met him face to face, but talked to him a number of times, and turned out the test he had modified from what was originally developed from the Navy was sort of and I came up with a much different test that was much better, and the company adopted that and improved the quality. I still remember, that's not Jeffrey's father. Yes, and be nice. Don't bring it up. And I didn't. All right, let's have some more fun with polyethers, alcohols, and how to make them. Now, let's look at this reaction, and I'll do that. And the question is, what's the product or products that are following? And we look at what's different. Oh, wait, I've got a benzene ring, but I also have a hydroxyl group on a benzene ring. That's an alcohol. Now, it turns out benzene will not react with ethylene oxide. Benzene will not react. That's part of learning general reactions. You know what will and what won't react. Now, because of that, I know what really we're dealing with is an alcohol plus, oops, I keep on putting a number where I should put the letter N moles, where this is N, of ethylene oxide. And what you get is this polyether alcohol, where N is the subscript number to the right of the bracket on the right that tells you how many times that OCH2 is repeated. Well, what's our? It's our benzene ring. Then I have my oxygen, O, CH2, CH2, what's N? 3, and there you go. Now remember, this reaction, I'll never give a synthesis. So when you're doing a reaction, this is probably the only one I'll maybe talk about some other things, but way later in the semester. The benzene ring won't react with ethylene oxide, so it's just an R group that comes along for the ride. don't forget to put the bonds inside. So I better give you one to try. And here's one for you. Now, instead of writing this whole out as an R prime group or something on a benzene ring, I'm just abbreviating it. That's just an alkyl group with 9 carbons and 19 hydrogens. So it's your turn. And as I look at the clock and where we are, we're right back on track. So it looks like test number 2 will be the date I have in my syllabus. And let's give everybody time to finish. All right, I think everybody's done. So it's my turn. And this starting material is called nonylphenol. 9 carbon alkyl group is called a nonyl group. Just like 1 carbon is methane. Nonane, drop the ANE, add YL, nonyl. But you don't need to know that. But what's different? We got a benzene ring, but this is ethylene oxide, and that won't react with benzene. But I got a carbon and a hydroxy group on the ring. This is an alcohol. And I have N moles. In this case, N is 9 moles of ethylene oxide. And what you make is this polyether alcohol. Remember, the hydroxyl group goes on the outside of the bracket. Common mistake, students. And here is N. Well, what's my R group? This whole thing here. And this 9 carbons and a hydrogen, this is an R alkyl group that comes along for the ride. Bracket O, CH2, CH2. What's N? This number, 9. And then outside the bracket is the hydroxyl group. Now, one of the things I said earlier today, and I'll repeat again, you should be asking the question, why am I learning this? Well, the obvious answer is you want to get a good grade in this class, but somebody said you had to take it. Oh, why learn this? And now a word of warning. Here, now, and later in the semester, I will talk about things, and I'm only talking about the organic chemistry involved. I'm in no way taking a moral stance on what I'm talking about, whether it's good or bad. I'm not talking about that. I'm talking about the organic chemistry. And let's look at this molecule you just made here, right here. And you made it by taking this nonylphenol alcohol reacting with 9 moles of ethylene oxide. And here's the molecule again, nicer drawn, and it has a common name. This is not IUPAC. Actually, you might even call this a trade name. It's called nonoxyl 9. Now, nonoxyl 9 is a surfactant. Surfactant is short for surface active agents, and I'll teach you more about it. But one of the main uses of this molecule is a spermicide. Yes, remember, I'm talking about the organic chemistry. And if you look here, this is nonoxyl 9, and here's the molecule. Here's your 9-carbon chain, R group that I had there, C9H18, benzene ring, bracket. Every bend in a line is a carbon, O, CH2, CH2, 9, and OH. Now, this is a spermicide. One place you'll find it, and again, I'm not taking any moralistic view of this. If you go to your local big box store, like the French store, my friend always likes to call it Target, that expensive French store, or Walmart, and you go to the section, and I've done this, where they have condoms. You can pick up a box of lubricated condoms, and you'll see on there contains the spermicide nonoxyl 9. Now, it's also used in cervical barriers as the diaphragm jelly when women use that as a contraceptive. Now, what I didn't know when I first looked this up a while ago, it's also used as a lubricant for shaving cream, which explains why men's face don't get pregnant. Now, another interesting thing as a surfactant, I'll teach you more about surfactants, it helps remove the chemical, and I'm not sure how to pronounce this, your eugenol, that causes the rash from poison ivy. You want to, I've never had it, but I know some people have. You want to rip your skin off, it's hurting, bothering you that much, and it's used for that. So the question is, why are you learning this stuff? Well, these reactions I'm teaching you are building blocks or tools like this one, organic chemists use, industrial organic chemists use to make molecules that are in your daily life. And this is an example of one of those. Oh no, we finished the ether epoxide problem set. And next Monday, I will go through the ethers epoxides problem set. Remember, this Wednesday, I'll go through the alcohols problem set. Keep up, we're moving at a quicker rate. And I do that every semester. I've taught this. Start out slow, give you a good foundation, and slowly pick up. I like the special effects. Slowly go faster, because I want to cover everything I'm supposed to. And we're done with that chapter. And you got to hold on, I didn't do this. And the new chapter is aldehydes and ketones. Now, before we start this new chapter, yay, new stuff, I have something I have to warn you about. If you're familiar with, how many of you are familiar with comfort food? When you're feeling bad, you eat that, it makes you feel better. Well, now you're going to know I'm an organic chemist. I have comfort functional groups. And Mother Nature and Dr. White loves aldehydes and ketones. So it looks like I'm having way too much fun this chapter. I am, because I really like them. I dealt with aldehydes and ketones for my PhD thesis. My first patent and last patent dealt with aldehydes and ketones. So aldehydes and ketones have been good to me, and I've been good to them. And I'm going to have a lot of fun. All right, what's an aldehyde? An aldehyde is a functional group with a carbon double bond to oxygen with an R group and a hydrogen. This is an aldehyde. And you can draw it this way or this way. Sometimes my software bend the line as a carbon. I don't put the carbon, but usually I'll write an aldehyde this way. And this is an aldehyde. And you can also write it, bring this hydrogen up here like this or like this. I like doing it this way because I just think it looks cooler. Later on, when we deal with sugars, my software will do it that way. And I'll show you remind you of this. So an aldehyde is a carbon, double bond to oxygen with a hydrogen and an R group. That's an aldehyde. Now, a ketone is a carbon double bonded to oxygen with two R groups attached to it, R and R prime. This is a ketone. It's not spelled with a Y, even though when you hear the name, you think it's K-E-Y-T-O-N. It's not. It's K-E-T-O-N-E. And I can write it this way here. So a ketone carbon double bond to oxygen and two different or two of the same R groups on there. Now, unlike an aldehyde, you can have a ketone in a ring. And Dr. White, Mother Nature, really love cyclic ketones. And notice I have this carbon, this, have carbons here and here, and they're disconnected together. So this also is a ketone. So ketone, carbon, double bond to oxygen with two R groups attached to it. Aldehyde, carbon, double bond to oxygen, and that carbon double bond to oxygen is an R and a hydrogen. Now, organic chemists are lazy, and a lot of the reactions, and when we get into reactions, I'll remind you, you can do it this way, or when you're talking about both ketones and aldehydes, you can write it this way, which is the way I normally do. And if R prime is hydrogen, it's a aldehyde. If R prime is carbons or benzene ring, that's what arrow means, it's a ketone. And that's just a lazy way of saying both. Now, probably one of the most important things in organic chemistry to me personally is the special name we give carbon double bond to oxygen. That's called the carbonyl group. The carbonyl group is a carbon double bond to oxygen. And if I'm going to be honest, if somebody were to ask me, Dr. White, what kind of chemist are you? In my heart of hearts, the only answer is I'm a carbonyl synthetic organic chemist. A lot of the work I've done in chemistry, both in my PhD thesis and as an industrial organic chemist, has been with the carbonyl group. And Dr. White loves carbonyl groups, and so does Mother Nature. I really do. And you should know how to describe with words and a picture, how to write and describe with a picture what is the carbonyl group. And the carbonyl group is a carbon double bond to oxygen, or you could say a carbon atom, double bond to oxygen or oxygen atom. And the way to draw it, and notice I have two lines. You want to put ours on there, it's okay, but you should know, hint, how to draw and how to describe with words what is the carbonyl group. And that's carbon double bond to oxygen. And both aldehydes and ketones have a carbonyl group. Now, it turns out other functional groups also have a carbonyl group. And it's important to understand, though it's called a group, it's not a functional group on its own like an alcohol is or an ether. The carbonyl group is found in many key functional groups. An example of that would be ketones and aldehydes both contain a carbonyl group. Now, I'll use this terminology. The carbon, and this I'll never ask on a test, but I'll use it in this class. The carbon of the carbonyl group is called the carbonyl carbon. And this would be the carbonyl carbon here. So the carbon, the one double bond to oxygen, is called the carbonyl carbon. I'll never ask that on a test, but I will use that terminology often in this chapter and others. Now, you should know one last time how to describe, how to draw, and how to describe with words what is the carbonyl group. And the carbonyl group is carbon double bond to oxygen, and this is the way you draw it. Now, let's talk about nomenclature. How do you name carbonyl or aldehydes and ketones? Let's do the aldehyde first. Now, I have it written here, but I'm going to go right to my whiteboard, and you can go back and I'll recover it again. Question is, give the IUPAC name for the following. How do you do that? Well, you look for what's different, what's not carbon, what's not hydrogen. Ooh, oxygen double bond to carbon with a hydrogen, and carbons on the carbon double bond to oxygen. And what is that? That's an aldehyde. And how do you name the aldehyde? You find the longest chain that contains the carbonyl carbon, that's the carbon, name a bond, double bond to oxygen, and you name it as an alkane. Then you drop the E and add AL ending. No number is needed. Because the carbonyl carbon that's the carbon bond, it's double bond to oxygen, is always number one. And therefore, I don't have to number it because it's always going to be one. So if we look at this molecule, how many carbons are in the longest chain? 1, 2, 3. That's propane. I'm going to drop the E, add Al, and that's propanol. And that's how you do it. Now, since you know this carbon is always number one, the rest of the alkyl groups, you do the same as you've done before. And why don't you try this one? Give the IUPAC name for that molecule. One thing I should mention, I learned it like I did with alcohols. Whenever I draw a carbonyl group, I always put it on the right. If you want to put it on the left, that's fine, but I don't. Good habits, Dr. White does not break or change. All right, let's do it. What do we have that's different? What's not carbon? What's not hydrogen? Ooh, carbon. Double bond to oxygen. That carbon has a hydrogen and more carbons. And this is an aldehyde. And how many carbons is the longest chain with the carbonyl carbon? That's the carbon double bond to oxygen. 1, 2, 3, 4, 5. That were an alkane, that's pentane. Since it's an aldehyde, I'll drop the E and add Al, pentanal. And the carbonyl carbon is always number one, so I'm done. Oh, let's do another one. And the question is, what's the IUPAC name for that molecule? Uh-oh, I'm having a bad hydrogen drawing day. That looks awful. That's better. All right, my turn. What do we have that's different? What's not carbon? What's oxygen? Double bond to hydrogen, a carbonyl group with a hydrogen and carbons. This is an aldehyde. And how many carbons the longest chain? 1, 2, 6, or I could have gone 1, 2, 3, 4. 6 is greater than 4. How do you name an aldehyde? Name the longest chain as an alkane. That includes the carbonyl carbon. That's carbon double bond to oxygen. Drop the E. Add Al. So 6 carbons is hexane. Drop the E, add Al, hexanal. And carbon 2, what do we have? An ethyl group. And that would be 2-ethyl hexanal. By the way, everybody, say hello to my very dear old friend, 2-ethyl hexanal. I found that this particular aldehyde, I could do things nobody else could, and that led to my first US patent. Yay! So 2-ethyl hexanal was my friend. I found when experimenting with it, I could do things to make certain things the company I was working at excel. Now, there are 2 types of nomenclature question. One is, here's the structure, here's the structure, give the IUPAC name. The other is, here's the name, draw the structure. And let me do one, then I'll have you have some fun. And the question is, how do you draw the following structure and draw the following compound from the following name? And we have 3-methyl heptanal. How do you decode it? You start from the right and move left. Al ending, aldehyde. And if the Al were E, heptane, 7 carbons. And it's an aldehyde, carbonyl, carbon double bond oxygen, hydrogen. Then as we keep on going, on carbon 3 is a methyl group. 1, remember the carbonyl carbon, carbon double bond oxygen is carbon 1, 2, 3. I have my methyl. I know there are 4 bonds to carbon. So I'll start putting in my hydrogens. Remember, it's your responsibility to let me know if I make a mistake. And there we have 3-methyl heptanal. And here's one for you to do. Draw the structure of 4-T-butyl decanol. Remember, I'm not going to be using TERT. You can, but I'm going to be a lazy organic chemist, and we just call it a T-butyl group. And for those who are finished early, please be patient. Try and give everybody time to finish. All right, everybody's finished. So how do you decode this to know what to draw? You start from the right, move left. Al ending. That's an aldehyde. Carbonyl, carbon double bond oxygen, hydrogen on the carbonyl carbon, R group. If this were E instead of Al, decane is 10 carbons, so I better get to work. And the N carbon, you can write on the right or left. I'm always going to do it on the right, because good habits I don't break. And this is decanal. And as we go this way, on carbon 4 is a T-butyl group. Remember, the carbonyl carbon is 1, 2, 3, 4, T-butyl group. And now I get to put in all these hydrogens. And there we have, remember, this is 10 carbons across, 4 T-butyl decanal. Now, you can't have an aldehyde in a ring. You can't. Ketones, yes. Now, there's one compound we already talked about in the lab. When R, remember, this is an aldehyde. When R is a benzene ring, the common name was also made the IUPAC name, and that's benzaldehyde. And benzaldehyde, if we were in face-to-face in the last week's lab, you would have smelled it. Smells like cherries and almonds. Some people can only smell the cherries. I can smell both. Whenever I see benzaldehyde, I think of Dr. Pepper, which when you smell it, I can smell the cherries. And I think of almonds too, almond paste or marzipan. You can smell it. So this is benzaldehyde. If you notice, I just went through this, find the longest chain, which includes the aldehyde to carbonyl carbon, name that as per an alkane, drop the E at the end of ANE, replace it with AL, and note the carbonyl carbon is always number 1, and name and number all the other substituents as per the IUPAC rules you already know for substituents or alkyl groups. Now, one word of warning. Remember, alcohol ending is OL. Aldehyde ending is AL. On test number 2, if you have an alcohol, make sure I can read that OL. On test number 2, if you have an aldehyde, make sure I can read the ending as an AL, not OL. You don't want me guessing, because I can make a 50-50 mistake. If I'm guessing, well, is that an A or an O? Well, that's important. So it's important when you're handwriting this, make sure for an aldehyde that Al looks like an Al. All right, let's have some fun with ketones too. Now, here's the ketone, and there are two different things I have to talk about, and I'll cover this in a second, but it's better if I do it as a example. Now, here we have a molecule, and the question is, look for what's different. What's not carbon, what's not hydrogen? Ooh, an oxygen double bond to carbon. Carbon's here and carbon's here. And this is a ketone. Now, how do you do acyclic ketones? And first, I'm going to talk about ketones that are not in a ring. You find the longest chain with the carbonyl carbon. Name it as an alkane. Drop the E at the end. Add ONE. I've never said the number one. I just say ONE. And you need a number. And I'll explain how you get that number now. So if we look at this ketone, it's got 4 carbons. That's butane. But since it's a ketone, I'll drop the E and add ONE, butanone. I'm not done. The carbon with the oxygen, carbonyl carbon, always has the lowest number. You start from the end of the chain. That's 1, 2. If I went the other way, that would be on carbon 3. 2 is lower than 3. So this is 2-butanone. And then the rest of the alkyl groups are the same. So find the longest chain with the carbonyl carbon. Remember, carbonyl carbon is the carbon double bond to oxygen. And then name it as an alkane, drop the E, add ONE, and you need a number. And therefore, give the IUPAC name for the following molecule. All right. So if we look at what's different, what's not carbon, what's not hydrogen, oxygen, double bond to this carbon, has carbons here, and this is a ketone. And how do you do that? You find the longest chain with the carbonyl carbon, and you name it as an alkane. 1, 2, 3, 4, 5, 6, 7. That would be heptane. You drop the E at the end of the alkane name, and you replace it with ONE plus a number. And therefore, ONE, heptanone. And what carbon is the carbonyl carbon? If I start this way, it's on carbon 3. I start this way, 1, 2, 3, 4, 5, and you use the lower number. So this would be 3-heptanone. And I've made it. I'm finished with that. All right, let's try one more. And here's that one more. Give the IUPAC name for the following, 3 points each. All right. If we look at this, what's not, and you're going to be tired of me saying this, but it's always true. When I look at a molecule, I look for what's different, what's not carbon, what's not hydrogen. Ooh, an oxygen double bond to carbon. Carbon's here, doesn't matter which is R and R prime. It's a ketone. Find the longest chain with the carbonyl carbon, name it as an alkane, drop the E, add ONE, and a number, and then the other substituents you name just like you've done in the past. So 1, 2, 3, 4, 5, 6. If I go there, it's 6, 2. That's hexane. It's a ketone, drop the E, add ONE, hexanone. Notice if I start from this side number, it's on carbon 2. If I did the other way, it'd be 1, 2, 3, 4, 5. So 2 is smaller than 5. It's 2-hexanone. And as soon as I say that, this is all spoken. Oh, it's your old friend, the methyl group. And it's on carbon 5. So it's 5-methyl, 2-hexanone. And that's how you do it. Oh my goodness, we're done for today. I hope you all enjoyed what we talked about today. Don't forget, on Wednesday, I'll go through the alcohols problem set. On Wednesday, we'll be doing the next lab, which is already available on D2L. And with that, except for the person I like to talk to afterward, I'm done for today. And I'll say, gang gesund. Goodbye now. I stole that from Granny of Beverly Hillbillies. Bye now. Bye, Louise. Bye.